All right, page 6 of that test review. Let me see real quick. Know how to find the expected value and standard deviation from a binomial probability distribution. When you see the word expected value, what should you be thinking? You should be thinking mean. And when you think of mean, you should be thinking mu. Whoa, that was ugly. You should be thinking mu. Man, there we go, mu. It's hard to draw mu on this screen, but expected value is the mean. Now, when I see number 12, what I really mean is number 11. And that was the one where we're talking about, you've got the 10 trials, I believe. Yeah, you've got 10 trials, and the probability of success was equal to 0.75. Now, continuing on, identifying the other things we need to know, the probability of a failure is going to be the opposite of 0.75, or the complement of that, which is 0.25. I think that's all we need. If you wanted to define success in words, you could, but that is all we need for this to solve these types of calculations. First one's asking for the expected value, and the expected value, like I said earlier, it's just the mean. If you have forgotten already what the expected value is for these types of binomial situations, I'll remind you. It is mu is equal to n times p. That's all it is. Very, very nice and handy. So in this case, our n is going to be 10, and our p is going to be 0.75. So our mu, when you calculate that out, is going to be 7.5. So what that means is our expected value, or our average, is 7.5. So our expected value of x is equal to 7.5. That is equal to our mu, or our mu is equal to our expected value. Either way you want to look at it, it works out to be that. So what that means is, in the long run, if you think about all of the examples that we're going to do, eventually you'll have 7.5 flips. Or if you did this experiment 100 times, the expected value in most of those would be about 7.5. You can't have 0.5 flips, but hopefully you're understanding where I'm getting that. Okay. Next step is going to be identifying the standard deviation. And we also know for standard deviation, we're not looking at number 12 again. This is going to be number 11. Sorry about that. So standard deviation using the same notation from above. What we're looking at now is we've got the formula for sigma is going to be equal to the square root of NPQ. So substituting in what we know, that's going to be the square root of 10 times 0.75 times 0.25. Typing this into the calculator correctly should give me a value of the square root of 1.875, and when you take the square root of that, you're going to get 1.369. So that is my sigma, my standard deviation, and it's going to be very, very helpful, because on the next question, it's asking me to determine if something was unusual. And when you see the word unusual, you should be seeing lots of alarm bells going off in your head, and you should be thinking about my minimum and maximum usual value. So remember, again, the minimum usual value is going to be mu minus 2 standard deviations, and the max standard deviation is going to be mu plus 2 standard deviations. We've already been identifying our mu and our sigma, so we can just substitute those in. And this first one, it's going to be, our minimum value is going to be 7.5 minus 2 times 1.369. And then our maximum is going to be 7.5 plus 2 times 1.369. When we calculate that out, our minimum and our maximum are going to be, our minimum will be 4.76, and our maximum will be 10.23. So what that means is any number of rolls that falls in between our minimum value. So in between 4.76 to 10.3, anything inside of here is what we call usual. That's a really ugly usual, but it's usual, and anything outside of that is unusual. And anything outside those values is unusual. So in our case, we're looking for 3 heads. 3 is outside of the range from 4.76 to 10.3, so that is unusual. All based on the rule of thumb. Let's see if I can draw a rule of thumb here. Let's see, here's my hand.